Hello everyone, and welcome to this new video. In today's video, we are building a minimal agent using LangChain and OpenAI and some tools. It's not official part of the series agentic AI, but I think it's coming at a very good moment in that series because in the series we are starting to see some code blocks from LangChain to support or to facilitate explaining the concepts that are related to agentic AI, especially with the core component like reasoning engine, planning, and memories, and so on. So today we will build a full agent from scratch. It's not a black box agent. We are going to build the agent completely step by step, so we understand exactly how agents work. By the end of the video, we will be able to understand what an agent actually is and how tool calling work under the hood, how structured tool inputs and outputs improve reliability, improves the structure of the agent and how it functions with the model and so on. How to implement a simple memory behavior with remember and recall. We will connect through an API to real web search, so we will get some news from the internet. And finally, we will do some tests, but we will expose our agent through a graphic user interface using Gradio UI. So basically, this video is ideal to start with as a beginner with AI agents, especially if you are using LangChain and its ecosystem. You will learn how to create the agent, debug it, work with the whole agent workflow from end to end, from the very beginning till the end. So we know from the previous videos in the agentic AI series how we moved from generative AI as model to agents that takes input using tools to generate output to agentic AI, where we are working with big objectives, sub agents, tools, and memories to pursue final output or achieve final output pursuing its own objective. So basically, as we know from the agent structure, it's not only the model itself. The model is part of the agent. It's the brain of the agent. It takes input, handle the input with the LLM itself, the model, and using some tools, it will generate an output. So the model will help us to decide what to do next, but the agent itself will decide the whole cycle between planning, acting, reflecting, update, and observe, and decide if it continues with another loop or it finishes because it reached its own objective. So what we have done today, we have created for this video a notebook. We are using Google Colab, and this notebook is fully annotated and fully runnable with a lot of explanation in the notebook itself. As we can see, we have a lot of comments here and descriptions for each cell, and each cell has its own structure and its own specific focus. So it improves readability of the notebook, as we see, and everything is well commented and basically runnable. We will go through this notebook step by step, but to give you an overview of what is in there. So in the beginning, we have the setup and dependencies. Then we define our tools, create the model, create afterwards the agent loop, and then we will simulate the memory behavior. We have the real web search, some test, and finally we will end with the user interface, a graphic user interface, where we can deploy our agent. So in the beginning, we are starting with some installation of some libraries, as we see. If you can read with me here, so we are talking about installing LangChain Core, LangChain OpenAI for the model, .env for .env loading, and then we have some requests for the Tavily search API code. Then we have the cell here that we can run together. Let's try. It's running here in Google Colab while it's running. Make sure that you are connected and you see the disk and RAM are already activated for you are connected to the environment. The next step is to configure the APIs. I use Google Lab Secrets here. As you can see, my secrets are ChatGPT key, Tavily API key. They are both here, and then I import them from the Google Colab user data. As you see, I stored them in the Open AI API key and Tavily API key, and then I just print them to confirm that they are correctly loaded. Grant access, grant access, and we see the API keys detected. The grant access happened because I didn't click these toggles here, but now they are on because I have granted access to this secret. Then we import the libraries that we will need: math, OS, request, etc. From typing, we are having any dict and list, and then we have the LangChain libraries that we will use, which are the chat OpenAI for the model, tool for tools from LangChain core tools, and from the messages we are using system messages, human messages, and tool messages, and so on. Let's run the sale. And it's taking some time, and everything went well. Then we move to define our tools, and here we are using the decoration at tool to define the tools. You will notice, if you are familiar with LangChain ecosystem, that there are plenty of ways to define tools in LangChain, but we are using this decorative to define our tools. Then we have the structured tools input. We are using we are defining calculator and web search. So here we are using expression string and precision integer, and query and top K integer for the web search. So LangChain is using the function signature, because every tool is a function in LangChain, or a Python function, and then the function signature and docstring are used to expose the JSON schema to the model, or to expose the tool itself to the model, and we will see how this will happen in a moment. So we have our first tool calculator, as we see the decorative here, a tool, and the definition of the function in this line, and then the docstring. So this tool actually is evaluating a basic math expression. Its inputs are expression, a string like etc., a math string, or a math formula or function, and the precision is the integer number of decimals for floats, if we want that, and then the output is the result as a string. And this is a very important part here, to tell the model how to use this tool actually. And then we have the body of the tool. Here we are defining the allowed characters, and then we calculate, actually we evaluate the expression as it is, and then we return the results with some exception handling. The second tool, which is the web search, again we are using the decorative tool web search, and then we have the docstring. Real web search using Tavily search API, input search query string, top K is number of results to return, and the auto compact text block with titles, URLs, and short snippets. Perfect. And then here we have the API. We are calling the API through its URL and its input that we will provide to this tool. After we get the results here, we handle the result and we return the result in the same format that we have seen here, which is titles, URLs, and short snippets. Then we have the two tools here, remember and recall, to simulate the memory behavior as we have explained, and we will see more on how we simulate this. The remember will save a node into the memory as a tiny memory store, and the recall will return the most recent nodes saved in the memory. Very simple one. After we define our tools, we map them, and that's for this block. Let's run. Everything went well. Here, tools are registered: calculator, web search, remember, and recall. Then we create the model, which is a simple make LLM function. We use the chat OpenAI with the GPT for Omni with a temperature 0.2. That's all. So we have our LLM ready. Now the system prompt. The system prompt is the first message that we will give to our agent, and it will act as a baseline for the agent, as a constitution or policy for our agent. So we are telling the agent who is, and we start by saying you are a minimal tool using agent. You have access to tools for calculator, web search, remember, and recall. We give it the here in the messages the input structure and the rules that it will function within. If a tool can help, call it. When calling a tool, provide a valid JSON parameters matching the schema, and then after tool results, decide whether to call another tool, more tools, or to provide the answer, the final answer, and keep a final answer clean. Don't mention tool calls unless asked, and use remember and recall to store and retrieve user provided information when relevant. Let's run this cell. Okay, perfect. All good. The agent loop, which is the core part of our agent here, and we are using the messages in this part to define our agent loop. So we are using self.messages and self.notes as the tiny memory store. The messages are the state, which constitutes from system messages, as we saw in the system prompt, user messages, the ones that we provide to the agent, and tool results, the ones that are resulting from the tool calling. So the workflow that will happen here with the system message, with the first call, we append the message, the user message, to the system message as a first call, and then we invoke it, we provide it to the model, and the model will decide what to do next, whether to call or to provide an answer. If the tool is called, we get the result from the tool, and we append it to the messages, and we invoke the model again, and it will tell us if it needs to call another tool or to provide the final answer. And it will continue like this until it provides the final answer or it reaches the max steps count that will prevent the agent from going into an infinite loop. And here, as we see, we initiate our agent, we provide the LLM, the large language model that we created just above, the tools that we defined, the messages, and we start with the system message with content system prompt, and then the nodes will be empty for the very beginning, and then the max steps is 8 as a guardrail. Execute tool. So we provide the tool name, tool arguments, and here we are simulating the memory behavior if tool name is remember, and here we add the message to nodes. We have the node to remember, we take it from the argument of the tool, and we add it, we append it to the nodes, and we return the invoke of the tool. If tool name is recall, we take the last messages, limiting it to 10, and if it's empty, if the node is empty, we return no message saved or not saved. Otherwise, we return the last messages or nodes recalled. And normal tools, which are the calculator and the web search, we call the tool. If the tool unknown tool function is none, we go to unknown tool. Otherwise, we run the tool with the we append the message, human message, and then we invoke the model with the messages that we have, and we get the results here, and we append the messages again with the tool called results, and we return max step reach if whenever we arrive to this one. Next, let's run this one. And here, as we see, our agents called minimal agent, LLM, system prompt, tools, etc. to define our agent. So our agent creation is well done now, executed. We defined the class, and then we created one instance from that class. Let's try to test now with our calculator. Let's see here. The prompt is compute 18 multiplied by 7 plus 2 power 10 and return the final number without any steps in between or any explanations. So here it says the agent output, the final number is 1150, which is a correct answer. Let's try the second tool test, which is the web search. Here we see search for top Spain football matches today, top K2, and summarize in 2 bullet points. Let's see what we have football matches for today. So the agent output is saying include live scores, etc., various leagues, including Copa del Rey, and key platforms for following these matches include etc., where we can watch these matches. So it doesn't say which matches actually, but it says that we have various leagues, including Copa del Rey, which is correct. We have the semifinals of the Copa del Rey today in Spain. The third test here, we will see the recall and remember, or remember and recall. So we start with the remember. So we're telling the tool here, or the agent, that remember that my project name is CoreDMap and I am building a minimal agent demo. And then we ask it to recall what we have asked it to remember. So the agent output, first for the first call, it says I have one node saved. And then when we call it for the recall the last 5 nodes, it says project name is CoreDMap and it is a minimal agent demo. There are no additional nodes recorded. It's only one node that we have recorded. So clearly our agent is able to decide which tool to call based on the prompts that we are asking it. And it's not the LLM answering us. Actually, it is our functions or our tools that are answering these questions that we are building here using the LLM. It's not without the LLM, but using the LLM as well. Here we are testing a multi-step search for top LangChain agent news, compute 12 multiplied by 12 is precision 0, remember, allow agents follow a think, act, observe loop, etc. Let's see what output we can get from this. And here we go. So the agent output, so it says recent news in LangChain includes introduction of agent builder template library, etc., etc. And the computation of 12 times 12 results in 144, which is correct. And then the notes, because we asked only to remember but not to recall. Here we asked only to remember. That's why it stopped here. So we see our notes now. It has 2 notes. The project name is CoreDMap, which is the first node with the first run that we had. And then we have the agent follow think act observe loop. So we have 2 nodes now that we got. If we want to make sure of this, we can add here a small code, and then we can, let's say, I'll copy this code here and go down, put it here. Let me just put it up. Yeah, let me run this one. So we have two agent output. It says here are two last saved nodes and agent follow, I think, act observe loop. This is the latest node. And then project name is called the map, and it's a minimal agent demo, and there are no more additional nodes. So clearly our agent is able to recall, to store in the memory and recall from the memory in a very good way. The last part of our demo is to do the Gradio user interface. So we are installing Gradio here. Then we are building the tracing here and our interface, which is correct. Here we're connecting the agent to the UI. I'm not going through the code here. It's well explained, but I just wanted to show you how this can be run actually and easily done. And then we will do the launch of our web interface. It's launched here inside, but I will use this link to open it. And we have some user guide here. If we scroll here, we see where the prompt. Let's say, who are the top tennis players? Oops. Who are the top tennis players? Let's see what it will do now. So here it tells us, we asked the question, who are the top tennis players? And what happened actually, here we have the answer. Some of the top tennis players, we get the men in the sport, like Novak Djokovic, Carlos Alcaraz, Yannick Sinner, Zverev, and Musetti, and so on. And here we see what happened exactly in our tool within the agent. So it says it did a tool call to web search. The arguments were top tennis players, top 5, and then the web search result, as we see, with a title, a URL, and some snippet of the from the search itself. So it's clearly worked very well as we wanted it to do. And then what another test is the square of pi. Let's see what it will do now. Well, it says the square of pi is approximately 9.86, which is correct. So it understood that we are asking of pi the math number, and it did the math.pi square, and it gave us the result, which is perfect. So what we have done today here is to build our agent that goes through the full cycle, the real agent loops, structured tools, memory behavior, and we have live web search with a usable user interface. So it's a full cycle of AI agent, all in one notebook, as we have seen, all annotated, runnable in a simple Google Colab environment, where you can move from here actually to customize this agent, let's say with other web search if you would like to use Bing search, other type of, or probably the internal knowledge management systems that you have. Probably add some SQL databases if you want. Add some document path to simulate or to try the different drag style workflows. Do other things to customize your agent and to deepen this agent to do better things and real world things. We just started with a demo here that can be useful to understand the agent loop from A to Z, and to continue from here towards the other agentic components that we were talking about, from the reasoning engine and the memory systems and so on. So that's all for today's video. And as usual, thank you for your time and attention. See you in the next one.